Hi everyone. Today we're going to evaluate definite integrals using integration by parts. Let's have this example 1. Evaluate the integral from 0 to 3 x over the square root of the quantity x plus 1 dx. For our solution, let us rewrite this integral showing that the radical here is a fractional exponent. And then we will show this x plus 1 in the numerator. Thus, we will have a negative exponent. So we have now the integral from 0 to 3 x times the quantity x plus 1 raised to negative 1/2 dx. We can observe here that both of the functions are algebraic. Now let us choose u. In choosing u, let us select the one which is easier to differentiate. So we let u to be that function x, and the dv is equal to the quantity x plus 1 raised to negative 1 over 2 dx. So du is equal to dx. Then we take the integral of the dv. For the right side, we need to use substitution. So we let another variable w equals x plus 1. So dw equals dx. Substituting now the values, of course, the left side here becomes v equals, by substitution we have now the integral of w raised to negative 1/2 dw. Using power rule, we have now w raised to negative 1/2 plus 1 all over negative 1/2 plus 1. The negative 1/2 plus 1 is positive 1/2. So w raised to 1/2 over 1/2. Let us simplify this 1/2 by flipping it up, thus making this denominator 2 be coefficient of w. So we have now the value of v as 2 times w raised to 1/2. From here, let us return the value of w with respect to x. That is the x plus 1. So the value of v is equal to 2 times the quantity x plus 1 raised to 1/2. Now, let us use the integration by parts formula. Let us substitute the corresponding values in the formula. So we have the u, that is the x, times v, the value is 2, times the quantity x plus 1 raised to 1/2, and then minus. Now we show the definite integral from 0 to 3 of v, which is 2 times the x plus 1, and the quantity is raised to 1/2, and du is dx. Simplifying further, the u, v can be combined together, so we have now 2x times the quantity x plus 1, and this is raised to 1/2, minus. For the integral here, let us move the constant 2 outside the integral sign. So we have now this 2 times the integral from 0 to 3 of the function x plus 1, this is raised to 1/2 dx. For the integral here, we need to do another substitution method. We let a variable s be equal to x plus 1. So we have here the ds is equal to dx. Substituting now, we have the integral from 0 to 3 of this variable s raised to 1/2 times ds. Using our power rule again, we have the s raised to 1/2 plus 1 over 1/2 plus 1. This 1/2 plus 1 is 3 over 2. So we have s raised to 3 over 2 all over 3 over 2. Let us simplify this complex fraction. This 3 over 2, we're going to flip it up, then making this number 2 coefficient of the s in the numerator. So we have now 2 times s raised to 3 over 2 all over 3. This time, let us return the value of s in terms of x. So we have 2 times the quantity x plus 1 raised to 3 over 2 all over 3. And from here, this is the value of this integral. Let us do the substitution. Writing again the value of uv and then minus 2 times this value now is substitute in here. Simplifying further, we multiply the constant 2 with that coefficient. So 2 times 2 is equal to 4. And from here, let us evaluate this function with respect to the limits of integration. So we have now the first function here evaluated with respect to the upper limit 3, then minus this function evaluated in here using the lower limit 0. Observing this second group, the 0 here as factor will make this expression be equal to 0. Then let us simplify further. This 2 times 3 is 6, and 3 plus 1 is 4, and this is raised to 1/2. Then minus, we copy this 4, 3 plus 1 is 4, raised to 3 over 2, all over 3. And then this minus and minus here makes this positive. So we have 4 times 0 plus 1 is 1, raised to 3 over 2, all over 3. Simplifying further, this 4 raised to 1/2 is 2. This 4 raised to 3 over 2 equals 8. This 1 raised to 3 over 2 is 1. Now, this 6 times 2 is 12. The 4 times 8 is 32. 4 times 1 is 4. Simplifying 12 minus 32 over 3 plus 4 over 3 equals 8 over 3. This is the final answer. Example 2. Evaluate the integral from 1 to e, x raised to 4 ln x dx. For our solution, let us analyze the category of each of the functions. The x raised to 4 is algebraic, while the ln x is logarithmic. With respect to our order of priority, the islate, the letter L comes first, then A of algebraic. So we use U as that ln x. So dv is equal to x raised to 4 dx. The du is equal to 1 over x dx. While we take the integral of the dv, we have now v equals x raised to 5 over 5. Let us now use our integration by parts formula. Let us substitute the corresponding values. The uv here is equal to ln x times x raised to 5 over 5. Then minus the integral of v, that is the x raised to 5 over 5, times the du, which is equal to 1 over x dx. Let us now simplify the UV into x raised to 5 ln x over 5 minus, let us move this denominator 5 outside, it becomes 1 over 5, and the integral of x raised to 4. So we simplify the x raised to 5 over x, and then the dx. We evaluate now this integral. We have x raised to 5 over 5, and simplifying this 1/5 times the 5 in the denominator here, we have 25. Let us now apply the limits of integration from 1 to e. Let us evaluate this function with respect to e, then minus evaluate this function with respect to 1. So we have now this expression minus this expression. Take note that ln of e is equal to 1, while ln of 1 is equal to 0. Substituting these values in here respectively, we have now e raised to 5 times 1 over 5, then minus e raised to 5 over 25 minus 1 raised to 5 times 0, that is the ln 1, all over 5, minus 1 raised to 5 over 25. Simplifying further, the 0 here in the numerator will make this fraction equal to 0. So we have now this e raised to 5 times 1 becomes e raised to 5, minus, we copy this fraction here, this minus and minus becomes plus, 1 raised to 5 is 1 over 25. Putting together these fractions with a common denominator, we have now 5 times e raised to 5 minus the e raised to 5 we just copy plus 1 all over 25. Please observe that we can combine this 5e raised to 5 minus e raised to 5, and that is 4e raised to 5 plus 1 all over 25. This is the final answer. I hope you learned something from this video. See you again next time.